Hello everyone, welcome to Applied Chemistry Tutorials. So today we are going to discuss about factorization using algebraic identities. Let's take a look on a few algebraic identities and later we are going to utilize them to factorize polynomials. Identity 1, a plus b whole square equals to a square plus 2ab plus b square. Identity 2, a minus b whole square equals to a square minus 2ab plus b square. Identity 3, a plus b whole multiplied by a minus b equals to a square minus b square. Identity 4, x plus a whole multiplied by x plus b equals to x square plus a plus b whole multiplied by x plus ab. Identity 5, a plus b whole cube equals to a cube plus 3a square b plus 3ab square plus b cube. Identity 6, a minus b whole cube equals to a cube minus 3a square b plus 3ab square minus b cube. Identity 7, a plus b plus c whole square equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. And identity 8, a plus b plus c whole multiplied by a square plus b square plus c square minus ab minus bc minus ca equals to a cube plus b cube plus c cube minus 3abc. Now we are going to learn about factorization using different algebraic identities. So let's start with identities 1 and 2. Identity 1 says that a plus b whole square equals to a square plus 2ab plus b square. Let us take an example. Factorize 4x square plus 12x plus 9. We are rewriting the problem statement first. 4x square plus 12x plus 9. And now we can clearly see that 4x square is a square term here similar to that of a square, and 9 is also another square term here similar to that of b square. So we are rewriting it as 2x whole square which equals to 4x square, and here 3 whole square which equals to 9, and reorganizing 12x as 2 multiplied by 2x multiplied by 3. So now we can clearly see that we are having a similar expression to that of a square plus 2ab plus b square, where a equals to 2x and b equals to 3. So we can rewrite it as a plus b whole square format. Here it will be 2x plus 3 whole square. Now this equals to 2x plus 3 whole multiplied by 2x plus 3. So this is the factorized form of the given algebraic expression 4x square plus 12x plus 9. Now identity 2 says that a minus b whole square equals to a square minus 2ab plus b square. We can see the difference here between identity 1 and identity 2. Here the second term is plus 2ab and here the second term is minus 2ab. So this is an expansion for a plus b whole square, and this one is an expansion for a minus b whole square. So let us take an example to understand it, how we can utilize this identity. Factorize t square minus 14t plus 49. So we are rewriting the problem statement here, and now we can clearly see that the first term t square is a square term similar to that of a square, and 49 which equals to 7 square similar to b square. So now we can rewrite t square as t whole square and 49 as 7 whole square, and we can reorganize minus 14t as minus 2 multiplied by t multiplied by 7, so that we can have that a square minus 2ab plus b square format. So here we can clearly see that a equals to t and b equals to 7. So we can put it in the a minus b whole square format to have t minus 7 whole square, and we can rewrite it as t minus 7 whole multiplied by t minus 7. So this is the factorized form of the given algebraic expression t square minus 14t plus 49. Let us talk about identity 3, which is a plus b whole multiplied by a minus b, and that equals to a square minus b square. Let us take an example how to utilize this identity to factorize an algebraic expression. factorize 9y square minus 121. We are rewriting it here, and we can clearly see that 9y square is a square term similar to that of a square, and 121 is another square term similar to that of b square. So we can rewrite it as 3y whole square minus 11 whole square. We can clearly see that a equals to 3y here and b equals to 11. So we can definitely rewrite it as a plus b whole multiplied by a minus b format, which equals to 3y plus 11 whole multiplied by 3y minus 11. So this is the factorized form of the given algebraic expression 9y square minus 121. Now from identity 4 we can have x plus a whole multiplied by x plus b equals to x square plus a plus b whole multiplied by x plus ab. Now let us take an example to understand how to utilize this identity to factorize an algebraic expression. Let us factorize x square plus 9x plus 20. One thing to notice here, this method is similar to that of factorization using splitting the middle term. So from the problem statement we are having x square plus 9x plus 20, and we can split 9 into 5 plus 4, so that we'll have 5 multiplied by 4 equals to 20, and here 1 multiplied by 20 equals to also 20. So it matches the criteria, and here also we can see that it matches the criteria here. X square plus 5 plus 4 whole multiplied by x plus 20, where a equals to 5 and b equals to 4, and ab equals to 5 multiplied by 4 or 20. Now let us expand it first. So we can have x square plus 5x plus 4x plus 20. So from the first two terms we can take x as the common factor to have x multiplied by x plus 5, and from the third and fourth terms we can take 4 as the common factor to have 4 multiplied by x plus 5. So from these two terms, if we take x plus 5 as the common factor, we will have x plus 5 multiplied by x plus 4. Instead of doing all this calculation by splitting the middle term as shown here, we can directly jump into the solution utilizing this identity mentioned here. So this is the factorized form obtained from the given algebraic expression x square plus 9x plus 20. Now let us take a look at identity 5, which is a plus b whole cube equals to a cube plus 3a square b plus 3ab square plus b cube. And let us understand how we can utilize it to factorize an algebraic expression. Factorize 8m cube plus 60m square n plus 150mn square plus 125n cube. And definitely we can see some similarities between this expression and this one in the problem statement here. Now we can rewrite it as 2m whole cube, which equals to 8m cube, and this 125n cube will be 5n whole cube. Now the terms in between 60m square n, we can rearrange it as 3 multiplied by 2m whole square multiplied by 5n, and 150mn square can be rearranged as 3 multiplied by 2m multiplied by 5n whole square. So we can see a clear similarity between the algebraic expression we obtain here with a cube plus 3a square b plus 3ab square plus b cube, where a equals to 2m and b equals to 5n. So we can put it in the a plus b whole cube format. So we will obtain 2m plus 5n whole cube, and also we can rewrite it as 2m plus 5n whole multiplied by 2m plus 5n whole multiplied by 2m plus 5n. So this is the factorized form of the given algebraic expression shown here. Identity 6 tells us a minus b whole cube equals to a cube minus 3a square b plus 3ab square minus b cube. So this is the expansion of a plus b whole cube, and this is the expansion of a minus b whole cube. And we can clearly see the differences here. So here the second term and the fourth term are positive, where here the second term and the fourth terms are negative. So let us utilize this identity to factorize an algebraic expression. Factorize 27x cube minus 189x square y plus 441xy square minus 343y cube. So we are rewriting the problem statement here. Clearly we can see that this algebraic expression is similar to that of a cube minus 3a square b plus 3ab square minus b cube. Now we can rewrite it as 3x whole cube, which equals to 27x cube, and here minus 7y whole cube, which is minus 343y cube. So now the terms in between, which are minus 189x square y, can be rearranged as minus 3 multiplied by 3x whole square multiplied by 7y, and plus 441xy square can be rearranged as 3 multiplied by 3x multiplied by 7y whole square. So this is very much similar to this algebraic expression where a equals to 3x and b equals to 7y. So we can rewrite it as a minus b whole cube format, such as 3x minus 7y whole cube, which further can be rewritten as 3x minus 7y whole multiplied by 3x minus 7y whole multiplied by 3x minus 7y. So this is the factorized form of the given algebraic expression. Now coming to identity 7, which is a plus b plus c whole square equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So let us take an example how to utilize this identity to factorize an algebraic expression. Factorize 625p square plus 64q square plus 81r square plus 400pq plus 144qr plus 450rp. So we are rewriting here the problem statement, and we can clearly see that there are some similarities between this expression and this expression given here. Now we can rewrite it as 25p whole square, which equals to 625p square, plus 8q whole square, which equals to 64q square, plus 9r whole square, which equals to 81r square. Now we can rearrange plus 400pq as plus 2 multiplied by 25p multiplied by 8q plus 144qr as plus 2 multiplied by 8q multiplied by 9r plus 450rp as plus 2 multiplied by 9r multiplied by 25p. So here clearly this is similar to that of a square plus b square plus c square plus 2ab plus 2bc plus 2ca, where a equals to 25p, b equals to 8q, and c equals to 9r. So we can rewrite it as 25p plus 8q plus 9r whole square, and further we can rewrite it as 25p plus 8q plus 9r whole multiplied by 25p plus 8q plus 9r. So this is the factorized form of the given algebraic expression here. Finally, we are going to talk about factorization using algebraic identity 8, which is a plus b plus c whole multiplied by a square plus b square plus c square minus ab minus bc minus ca, which equals to a cube plus b cube plus c cube minus 3abc. Now let us take an example to see how we can have algebraic expression similar to a cube plus b cube plus c cube minus 3abc, and how we can factorize it in the given format mentioned here. Factorize 27x cube plus 216y cube plus 1331z cube minus 594xyz. So we are rewriting the problem statement here, and we can clearly see the similarities between this algebraic expression here with this one. Now we can rewrite this expression as 3x whole cube, which equals to 27x cube, plus 6y whole cube, which equals to 216y cube, plus 11z whole cube, which equals to 1331z cube. Now we can rearrange minus 594xyz as minus 3 multiplied by 3x multiplied by 6y multiplied by 11z. So here this is similar to that of a cube plus b cube plus c cube minus 3abc, where a equals to 3x, b equals to 6y, and c equals to 11z. So now we can rewrite it as in this format, which is 3x plus 6y plus 11z whole multiplied by this second factor here. So 3x whole square plus 6y whole square plus 11z whole square minus 3x multiplied by 6y minus 6y multiplied by 11z minus 11z multiplied by 3x. So on further simplification, we will have 3x plus 6y plus 11z whole multiplied by 9x square plus 36y square plus 121z square minus 18xy minus 66yz minus 33zx. So this is the factorized form of the given algebraic expression 27x cube plus 216y cube plus 1331z cube minus 594xyz. So these are the different identities we have shown here, and we have also shown with example how to utilize those expressions to factorize different polynomials. And in our next video we are going to discuss about another method to factorize polynomial. And if you like this video, give us a thumbs up and share. Also, please subscribe to this channel. Thank you.